As you have seen in the YouTube video, the modern weaving process is highly involved with many technical terms. We are going to focus on just the things that are necessary for you to know about when creating garments and other stitched articles. First, we need to get the hang of a few basic geometry concepts. They are degrees and angles, simple fractions, and perpendicular lines. We have one simple circle. Divide the circle in two halves. Divide the two halves in 4 quarters or quadrants. This is also known as 4 fractions of the whole circle. When the quadrants are exactly equal, it gives us 2 lines which are perpendicular to one another. This is also referred to as right angles. If any one of these 2 lines are not at a right angle, the lines will no longer be perpendicular. In each quadrant, there are 90 degrees radiating from the center of the circle. Here I have drawn only 15 of them for you. Each quadrant containing the 90 degrees together form the 360 degrees to make up the full circle. One of the important reasons why I'm telling you all this is because the 45-degree angle is something very interesting in a plain woven fabric. We'll get to that. When preparing a loom for production, thousands of very long and strong threads are tied to the machine. These are called the warp threads, and in the finished fabric will run the entire length of the roll of fabric. Warp threads are usually stretch resistant. For a plain weave, every second warp thread is run through heddles on a shaft. These heddles are usually made of metal and are placed very close together. They are also very small on top of this shaft. Let's call these warp threads the ones. The twos are threaded through the heddles of a second shaft. These shafts are used to separate the warp threads while the shuttle or rapiers pass between them. These secondary threads are called the weft. When the shuttle turns after each passing, the weft forms loops on either side of the fabric. These long sides are called the selvage. The warp threads and the weft threads are perpendicular to one another. And that is how a plain woven fabric is constructed in a 1 over 1 under fashion. Let's take a closer look at actual fabrics. The warp threads or straight grain always run parallel to the selvage. This is what the selvage looks like when rapiers were used to weave through the weft threads. The threads are cut on the sides of the selvage of the long roll of fabric. This small piece has only one. On the other side, it was much further away and is now cut off. I have here a quarter size pattern. We need to know about the straight grain of fabric. There are lines printed on the pattern pieces. Here they are. They need to line up with the straight grain of the fabric. This will greatly affect the hang and fit of a garment. To double check which is the least stretch direction of the fabric, test the one side and you'll see there's very little stretch, whereas on the other direction there is more stretch, confirming that the straight grain runs in this direction. Earlier in this chapter, I made mention of the 45-degree angle in wovens. Here are our perpendicular lines again. Very little stretch in the warp, a little more in the weft, but in the 45-degree angle, there is an enormous amount of stretch. This is known as the true bias. When a garment is cut on the true bias, it will conform to the curves of the body. When a garment is cut on the grain, all sorts of techniques are implemented to get rid of the fullness of the fabric so that the garment conforms to a three-dimensional shape. When the garment is cut on the bias, it conforms to a curved shape. Strips can also be cut on the bias of the fabric to create bias binding. Bias binding is an incredibly useful invention for a myriad of uses. Bias binding will be covered in a later chapter. In this particular fabric, the warp threads were used to create the pattern. If I remove some of them, you'll soon see how this was achieved. All the weft threads are of a cream color. I have never bought a piece of fabric that was cut straight in the shop. The only way to be sure it is dead straight is to tear the fabric. Be very careful because some plain wovens will tear anyway and you can lose a lot of fabric that way. So let's imagine this is that skewly cut piece of fabric from the shop. It is very important to get both threads straight. Your warp parallel to the selvage and your wefts very skew. And you know this because some of them are short. They are continually becoming longer as you pull them from the fabric. You need to continue removing these threads until you can remove one that is the entire length of the width of the fabric. The next one will come out in its entirety as long as the fabric is wide. That new line indicates the grain of the fabric. This line indicates the straight grain of your fabric to be lined up with pattern pieces. This plain weave is called gingham. Gingham has a very special way of weaving to create a pattern. These white threads are interwoven with grey threads. The same amount of white, then grey, then white, then grey, repeated throughout the entire fabric to create this checkerboard effect. What's interesting to notice is when white threads cross white threads, you have a white block. When the grey and grey cross, they create a grey block. When white and grey intersect, this kind of grey is achieved. But on the other hand, a different kind of grey is achieved when the white and the grey intersect, offset from this. Somehow, 4 different shades are achieved. Grey 1, white, grey, and grey 2. There is something very important to note about woven fabrics. Although I have removed an entire thread from this side, obtaining the straight grain, as well as on this side, obtaining a straight grain. Putting the fabric on top of a piece of paper that is square or at right angles, you can see that the fabric is skew. This is quite normal in fabrics that have just been bought. The fabric should be straightened out by pulling it on the bias until the sides are square before cutting your pattern pieces. This fabric is not a plain weave, constructed in the normal 1 under 1 over way. The striped pattern in this fabric is achieved when these blue warp threads are caught by the wefts periodically. This is an example of artificial suede. It's a pity you can't feel the characteristic of this fabric. Suede is the wrong side of natural leather. It sort of has a resistance to it, almost like it's rubbery. The characteristics of the suede is achieved by the content of these fibers, as well as the way in which it was woven. The threads in this direction, I cannot tell you whether it's the warp or the weft without testing for stretch, but these ones are quite smooth and flat, whereas the opposite ones have some kind of lycra or rubber content to them. They are also woven in a slight zigzag fashion, which protrudes on this side of the fabric, creating that specific characteristic. If you have a look at the other side of the fabric, it is quite smooth and there is none of that pile forming on that side. Also interesting, the pattern in this case was printed on the front of the fabric. There is no sign of it at the back. In this fabric, we can see how different colors of threads that have been woven together form an entirely secondary color. Here we have light brown threads interwoven with black ones, forming a fabric of a color that is somewhere in between these two colors. This example of cotton shirting, again, the pattern was created by the use of different colors of threads. What's interesting about this one is that there is a little flower motif repeated here. If you turn the fabric over, you will see that there is a loose thread at the back. And only where the little flower is required on the right side does it jump through and show. Here we have two different kinds of plaids or checks. The first one is a very high quality material where the pattern was woven in. If you turn the fabric over, you will see that the pattern continues the same way as the pattern does on the front. This one, on the other hand, the pattern was printed on top of the fabric. If you take a closer look at this kind of weave, you will notice that tiny diagonal lines are caused. This happens when a certain amount of threads are jumped every time the weaving process takes place. In other words, it's not a plain weave, it's a twill. This one is a plain cotton fabric that has been printed, as I said. Here you're going to run into enormous problems if you use this material for something like curtains. Your grain of the fabric is here. You would cut your fabric on that line. Measure upwards the amount that you want to use for the hem. Obviously it will be the same on either side. You can imagine what kind of problems you are going to run into when you do this hem. Your lines are always going to be skewed. Unfortunately, there is no way to remedy this. So to my mind, this fabric is entirely useless. We come to an example of the fabric that was referred to in the YouTube video in the beginning. This is jacquard weave. In medieval times, it was extraordinarily expensive. Only royals and very wealthy people could afford it. One poor sod would sit for a month to make a meter of this kind of fabric. I'm glad I don't live in those times. The design of this fabric is intricate, and you can see that different colors are used to make up the design. But not only different colors, different techniques of weaving are implemented here. Also, you'll notice that there are very fine and very many threads in this direction. This is a man-made fabric. It's completely synthetic. What's interesting about this one, apart from the fact that it's machine-made, is that you will turn it over and only then will you discover one of its secrets. The color bands run in stripes at the back that you don't notice when you look at the front of the fabric. Lastly, in this section on weaving, I would like us to look at some labels. In this case, you can see the silver threads are there present all the way through at the back. But on the right side, they only jump to the front, and this is all done by computer, telling each little thread what to do, when to do it, and for how long to do it. Just love labels. That would be looking at them, not wearing them. Same with this one. The red thread is present at the back, all the way through. Jumps to the front when it's required. my favorite for many years in the classroom. Seems like an intricate design at the front, but I have no idea how that computer knows what to do, because at the back there's a whole lot of craziness going on.